All right. What we're going to do today is something that's going to look very and feel very familiar and similar to what something we've done before. We're going to be solving inequalities, and today we're just going to focus on addition and subtraction. But I think you're going to find that solving inequalities are very similar to solving inequalities. However, there's one difference that actually I think you're going to appreciate. I think you're going to like it. I'm not going to tell you the difference yet, but once we get to it, again, I think you're going to be a little relieved. You might like this difference quite a bit. Here we go. Can't wait to show you. All right. So here we have an inequality. X minus 4 is greater than 12. Now, we could probably figure out what x would be. However, solving it or getting the x by itself, getting rid of this minus 4, might help us understand the inequality more easily, because then we don't have to deal with that minus 4 there. So the first step to solving an inequality is writing x minus 4 is greater than 12. We're just going to rewrite it. Okay? Now, this is where the similarities come in. Because you're going to say, wait, this looks very familiar. Here we go. Right here, there's the greater than symbol. We're going to put the wall. Oh, the wall's back. Oh, that's nice. Now, again, our goal is to get the x by itself. We want to isolate the variable to figure out what x could be. So what we're going to do to get rid of that minus 4, we're going to do the inverse, the opposite. We're going to add 4 to both sides. And again, this should look very familiar. So what happens here is that minus 4 and the plus 4, they cancel out. And we're left with x. Now we have to make sure to keep the right symbol. X is greater than, x needs to be greater than 12 plus 4 is 16. Now you might be thinking, okay, well, now we have to check it. Well, we can't really check it because, remember, inequalities have an infinite number of answers. There is an infinite number of numbers that are greater than 16, like 17 or 18 or 16 and a half or 16.1 or 19 or 20. We can keep going. But there is no check for this. All we'd have to do is find the inequality. Now, one way you can kind of check it without writing it down, though, this is a good idea, is actually put 16 in there. 16 minus 4, well, x actually has to be greater than 16. So let's try a number greater than 16. Let's try, 17. See if it works. 17 minus 4 is 13. 13 is greater than 12. So that checks out. Any number greater than 16 would work. But that's how you would solve an inequality. All right, let's solve this addition inequality. Let's write it down. X plus 5 is less than 11. We'll put our little wall. We want to get rid of that plus 5. We want to get the x by itself. So we're going to subtract 5 from both sides. The plus 5, the minus 5, they're gone. And you're left with x. Now you got to make sure to keep that inequality symbol. That's going to be the less than symbol. 11 minus 5 would be 6. So any number less than 6 would work for this inequality right here. Let's see. 1. Let's try 1. 1 is less than 6. 1 plus 5 is 6. 6 is less than 11. So that would work. So I'm feeling pretty good about that one. There's our solution here. X has to be less than 6. So now we're going to try a couple more. But after we solve it for the ones below here, we're actually going to graph it too. We're going to graph our solution. And what's nice is that these graphs already have numbers on them. So there you go. That's one less thing we have to do, I guess. All right, let's solve this. We got x plus 7. I'm going to make sure that that 7 looks like more like a 7 here, is greater than or equal to 10. So again, there's a bunch of different numbers that would work for this. Let's find out what would work. Let's put the wall through there. We want to get the x by itself, so we shall subtract the 7 from both sides. We want to get the x alone. Minus 7 on this side, minus 7 on the other side. Whoop. What happens to plus 7 minus 7? They're gone. And what we're left with is x is greater than or equal to 10 minus 7 would be 3. So let's just double check that here. What's a number that's greater than or equal to 3? 5? 5. Let's check 5. 5 plus 7, that's 12. Is 12 greater than or equal to 10? You bet. You bet it is. So now here's our solution. We're going to graph the solution. We're going to graph all the numbers that would work here. All right, so x is greater than or equal to 3. So we're going to use the closed dot because it's or equal to, closed dot. And we want greater than or equal to 3. So we're going to go into the greater than, oh geez, just crushed the graph right there. The number is greater than or equal to 3. I know it's kind of hard to see, so I'm going like along the top of the line here. So I'm going to put my arrowhead here. Okay. So I did my best to try to make it a darker line so you can see it a little bit more clearly. Okay. So it's kind of combining things from the last unit. It's combining things from this unit too, like the graphing of the inequality. So this is kind of like the next step in inequalities, is solving and graphing. So let's try this one here. Y minus 3 is greater than 9. Y minus 3 is greater than 9. Well, let's see what y would have to be to make that true. We're going to put our little wall there. We want to get the y by itself. So we're going to add 3 to both sides. We're going to do the inverse, the opposite. So let's add 3 to this side. We'll add 3 to that side. 9 plus 3 is 12. I probably should have done the other side first, but those cancel out. You get y, and then what am I missing? I'm missing the symbol. Got to keep the symbol. We're going to keep that symbol the way it is. We're going to keep it at, doesn't look like an L. That doesn't look like an L to me, so that's the greater than symbol. Y is greater than 12. All right, so this is the first one we've done a little bit like this. We actually need the open dot. Open dot, because y needs to be greater than 12. Y cannot be equal to 12. So we're going to go to 12. Y cannot be 12, so we're going to put the open dot. But y can be anything greater than 12. So we're going to go in the direction of the numbers that are greater than 12, like so. Whoop. Nice. All right, now if you want to try these next two on your own, go for it. If you want to pause it and try them, that's fine. But I'm going to do them as well. But you should be able to handle these pretty well, because again, this is nothing brand new. The only thing brand new is that we have a symbol of inequality instead of an equal sign, and we're not checking it. So there you go. We're not checking it. Well, we are kind of checking it just to make sure the numbers we get make sense. All right, n plus 2 is greater than 5. So let's do the wall. We want to get the n by itself. To undo the plus 2, we're going to subtract 2 from both sides. Minus 2. That cancels out, and we're left with n has to be less than or equal to 5 minus 2 is 3. Let's just check that real quick. What's a number less than or equal to 3? I don't know. 1. Let's try 1 again. 1 is less than or equal to 3. Let's see if 1 would work. 1 plus 2 is 3. 3 is less than or equal to 5. That checks out. Feeling good about that. So we're going to use the closed dot again because we have the or equal to symbol. So it's going to be n is less than or equal to 3, meaning we're going to circle that, or close that dot there. Close the dot, because 3 would count. Forgot to circle that answer. I'll circle that one too. Solution. Okay. Let's see. Check the symbol. N has to be less than. That's a little L there. Less than or equal to 3. So we're going to go less than. These arrows are a little bit easier to see because the line's a little lighter, so that's nice. All right, so there's all our solutions are there. So 0 would work too. 0 plus 2 is 2. 2 is less than or equal to 5. So anything above that, though, would not work. 4 would not work. 5 would not work. 6 would not work, and so on. All right, last one. Again, you can try this one on your own. We should feel pretty confident about this at this point, having done it in equations. Okay, so we'll wall. We want to get rid of that minus 3. So we're going to add 3 to both sides. Okay, let's see what happens here. Minus 3 plus 3, those are gone. we're left with y. Uh-oh. Oh, I just realized something. We've already done this one. Okay. So if you wrote in pen, you can just cross this off. I'm going to change this one. I just realized this one's the same exact one as number 2 on the same page. So I'm going to change this one real quick. I'm going to cross that off. You can cross it off too. We're going to do instead, I apologize, y minus 5 is greater than 6. Okay. That's different enough, I suppose. All right, let's try that one instead. Y minus 5 is greater than 6. So in case you had to cross it off, we can do it over here, I suppose. Y minus 5 is greater than 6. Okay, so we'll put the line through there. We have to get rid of the minus 5 by doing a plus 5. Do plus 5 on both sides. Minus 5 plus 5 cancel out. And we get y has to be greater than 11. Y has to be greater than 11. There's our solution right there. Okay? All right, so here's 11. We're thinking, is it going to be an open or closed dot? Well, y has to be greater than 11. We're going to start at 11, but we won't include 11 because it's not or equal to. It's just has to be greater than. So we're going to use an open dot there. And we're going to go in the direction of greater than. Y needs to be greater than 11, so let's do it. I'm just going to check one of these numbers real quick. Let's check 14. Let's see if 14 works. 14 minus 5 is 9. 9 is greater than 6. Yeah, that checks out. So again, I apologize for the, see if you see here, those two are the exact same thing. So that's why I changed it. So I appreciate your patience as we change that. And I hope that this went well. Again, it's very similar to something we've done before. We're going to continue this next time you're in class. But let me know if you have any questions, and have a great day. I'll see you soon. Bye-bye.